Okay, this is total change basic problem 5. All right, so at the very beginning of the problem, it says that a train is speeding up. So what you should take this to mean is that ds dt is an increasing function. Is an increasing function, okay? So ds dt, think of increasing as you read from left to right, the graph goes up. Okay, so ds dt is an increasing function. That's what this means. Okay, so here I have the data that they give you in the chart. So so we don't know what ds dt looks like. Okay, that's the first thing to kind of figure out, is we don't know what ds dt looks like, but we know it's increasing. Okay, and we've through experimental data or what have you, these are we know 2 data points. Okay, so one possibility for ds dt might be something like that. That's an increasing function. Another one might be that. That's increasing too, right? Another one might be that. You know, we just don't know what ds dt looks like, but we do know it's increasing. And we do know that at 0, ds dt is 25, and at 2, ds dt is 28.4. That's what we get from the data. Okay, so now what we want to do is we want to approximate the area under, the amount of space under ds dt. So let's say that that's our graph of ds dt. The total change is this area. The total change is that area. Now we're going to approximate that area. Okay, if we use a left-hand approximation, then we use the left endpoint of the interval, which is 0. So the left endpoint, which is 0, 25, and we just draw a straight line across, and we find the red area, which is easy to find because it's a rectangle, right? You can see that that is an underestimate of the actual total change. That's the left endpoint. That's what we're going to use for this problem. For problem 6, you want a right-hand endpoint approximation. If you wanted a right-hand endpoint approximation, then we would use this as our height of our rectangle, and we'd use all of it here. There we go. So all of it. In which case you could see that our estimate would be an overestimate. All right, so let's go ahead and compute the area of the red rectangle there, our left-hand approximation. So this red rectangle here this is the area of a rectangle, right? So area of a rectangle is easy. This is 2 times 25. We know. And as I said before, right, we don't know what ds dt looks like, right? It could be the one I have drawn here. It could be this one. But it doesn't matter, right? You can see that the area under this curve is bigger than the area that we figured out here. That's why it's an underestimate. Okay, so you're going to have to draw pictures like this for each of the problems, and that's how you'll figure it out. All right, good luck.